All right, calculating, comparing square roots. Now, there's some stuff in your book that was really hard to kind of put into this type of format because there's not necessarily symbols that you can make just typing. Your keyboard doesn't always work really nice for math symbols and those kinds of things. Neither does just Smart Notebook. But we're going to talk about square roots and perfect squares today, and I'm hoping that you're already fairly familiar with perfect squares and maybe some square roots. Right? We're not going to talk about maybe the super complicated ones. I will show you a couple of tricks on how to simplify some square roots, because I think if you're introduced to that now, it's going to help you out later on. But a perfect square is a number that is a square of an integer. The product of a number in itself is a perfect square. Let's talk about some perfect squares. Can anybody name a perfect square for me? 4. Yep. 4, right? Because 4 is what? 2 times 2. All right. What? Can anybody tell me what maybe the first one is? 1 times 1 is 1. Right? We could even go with 0 times 0 is 0. So if we make a list, right? Let's just go up a list. Let's start with 0 is a perfect square, right? And 1 is a perfect square. What else? No. 4. All right. 9. 16. All right, do it like this. This is the perfect square of 0. This is the perfect square of 1. This is the perfect square of 2. Perfect square of 3. Perfect square of 4. Right? That's going to help me find the next one, which is 25, which is the perfect square of 5. All right, what's the next one up here? 36, because that's the perfect square of 6. And then 49, which is the perfect square of 7. And then 64, very good. That's the perfect square of 8. Then we have 81, which is the perfect square of 9. And we have 100, which is a perfect square of 10. Let's stop right there. We could go further. We could go 121, which is 11. Then we jump to, 169? No, 144, which is 12. 169 is 13. I don't think I know. Is it 256 is 14? Very good. I wouldn't have probably jumped on that. 196? 196 sounds right. And then 15, I think, is 225. That's probably as far as I can go, okay? And I didn't even, have all of those just down in my head. But those are all perfect squares, right? Which means if I took one of these numbers on the top row and put it underneath a square root symbol, I would get the corresponding number that's below it, right? The square root of 81 is 9. You follow me? Because it's the root of it. Okay? So a perfect square is a number that is a square of an integer, which is the product of a number in itself. Square. There is a number here that you don't see. Does anybody know what number goes in front of this square root? It would be 2, because we're taking that number times itself, okay, which means I see that number twice. Okay? The reason that's important that we understand there's a 2 there, even when we don't see it, is because later on in math you'll work with things like cubed roots and fourth roots and so on and so forth, right? So the smallest root that we can do is a square root. Right? Does that make sense? Okay. So a square root is indicated by a radical symbol, which is this guy right here. Right? That's a square root. Notice that it's different than a division bar, right? When we talk about division, we just see that, correct? This has a little curly doodad at the front end of it. And what this is called, because it's not always a square root, right? If I could put a 3 in there, now it's a cube root. What we call that by itself is a radicand, is the number or expression under a radical symbol. Or I'm sorry, that's not the radicand. The radicand is whatever number goes here. That's the radicand. Okay, it's the number underneath that radical symbol. Okay, I don't want to call it a square root symbol because it's not always square roots. Okay, we'll just call it a root symbol or a radical symbol. All right. So a square number can only end. This will just kind of give you some hints whenever you look at a number, right? We looked at several, that we made a list of from 0 to 100, and we talked about them clear up to 225. But let's say we want to know, is a number a perfect square? But we can't remember if it's on the list or not. Well, every perfect square either ends in 0, 1, 4, 5, 6, or 9. Okay, let's go back and let's see if that's true. Okay, 0, 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. You see there, it's always the same things, right? Right? Okay, so that's an indication. So if I saw, I wanted to find when it was a really big number, let's say 147, right? I should know off the bat that that's not a perfect square. Okay? For instance, I should know that, well, the closest thing to 147 is 144, right? And that's too close to 144 for 147 to be a perfect square, because you'll notice that perfect squares are pretty well exponential in nature, right? Because the next thing after 100, what did we say was what? 121, right? There's a jump of 21, right? From 0 to 1 was just 1, and then we went 3, and then we went 5, and then we went, 7, and then 9, right? And odd numbers going up, okay? So, but the differences between those perfect squares numbers is getting bigger and bigger and bigger as we go. All right. All right. However, not all numbers ending in those digits are perfect squares. For instance, 6 is not a perfect square, even though 36 is a perfect square. Does that make sense? So not every number that ends in one of those numbers is a perfect square. Not all numbers are perfect squares, but their square roots can be estimated, which means what we can say is that although 47 is not a perfect square, we can still find the square root of 47. Okay? And we can get close. There won't be an exact number, it'll be a decimal, but we can estimate it. When comparing expressions that contain radicals, we want to simplify the expression with radicals first, and then we want to perform any operations necessary, then compare those expressions. That seems really wordy, but let's look at some examples here. Let's see, lesson 13. All right, some of these are really easy. What's the square root of 25? 5, okay? This one might throw you a little bit because you see that there's a negative out front, but just ignore the negative for now. What's the square root of 121? Okay, basically what we're saying here is negative 1 times the square root of 121. So what's negative 1 times 11? Negative 11. So we'd get that right there. Does that make sense? You simplify the square root first, and then you deal with anything outside of that square root. Okay, does anybody have any problems with that? No? Okay, good. All right. And then we get into something a little trickier. Look at this. This says the square root of 44. And we can use our calculator to check. What does 44, what perfect squares show up on either side of 44? 49. And what else? What's on the other side? 36. Okay? So here's what we do. We know 44 is not a perfect square, but we know that it's going to be between 6 and 7. Does that make sense? Okay. Is it closer to 36 or is it closer to 49? Well, from 44 to 49 is 5 away. How far is it from 36? 8. Okay, so it's a little closer. So notice that it's going to be 6 point probably over 5 because we're closer to 7 than we are, just 6. Right? 6.633. So, but what we were going to do is that, let's see, what does our answer come out to in this question? Because it's a little close. Actually, no, we would say 7 because it's going to be close. Actually, they say 6. Is it 6? What does it come out to? Square root of 44 is what? See, this is where I would disagree with the answer key here because 6.633 is going to round up to 7. Okay, so I would disagree with what I think is, let me check here in their answer key on this. Let's see, we're on question number 3. Yeah, and they're saying A. Yeah, okay, so I just wrote it down wrong. It is A. They weren't wrong, I was wrong, but it should be 7. Okay, does that make sense? Okay. All right, let's look at number 4. Now we're getting into a little bit of a word problem. A square mosaic, okay, which means it's got tiles, small glass squares. There are 196 small squares in a mosaic. How many are along the edge? So we're taking a number times itself, okay? What's the square root of 196? 4. All right, well, we know it's greater than 12, which is 144. 13 is 169. What is 14? 14 is 196. So our answer should be 14 squares because it is 14 by 14, and it's going to fill it in with 196, right? So along one edge, there should be 14. Right? And along this edge should be 14. Okay? Now, what could have been confusing about that is that if it was asking for, like, what is the perimeter, then we would have had 14, 14, 14, 14. A little, yeah. All right, so we would have taken, 14 times 4 to find a perimeter. But they're just looking for along one edge. Along one edge, there should be 14 squares, right? Okay. All right, number 5. Similar, it says the area of a square garden is 88 square meters. Is 88 a perfect square? No. All right, so what perfect squares does 88 show up between? 81 and 100. How far is it from 100? 12. How far is it from 81? 7. So what is it closer to being? It's closer, and the square root of 81 is 9. So to the nearest whole number, it should be 9. Does that make sense? What is the square root of 88? Can anybody tell me? No. It should be 9 point. And it should be less than 5, less than 9.5. 9.3. So that's going to round down to 9, right? Do we understand this yet? Hopefully. Okay, good. All right, because a lot of these are just dealing with estimation. All right, estimate the value of the square root of 122. All right, 122 is closer to what perfect square? 121, right? And it's really close to it, right? So what should the square root of 122 be closest to? 11. So 11 is our nearest integer. How are we doing? Everybody in the back is good? All right. The area of a square rug is 144 square feet. Oh, gosh. It's been a long couple of days. What is the side length in feet of the rug? 12 feet. Okay, because the square root of 144, because remember, it's a square, right? So length times width, it's going to be the same number in length as it is width. Square root of 144 is 12. Oh, okay, now we've got on number 8, the area of a square tile is 289 square inches. How many inches long is one side of the tile? So square root of 289. Is it 17? Yeah, 20 is 400, so it's not that big. 15 is 225, isn't it? So it's got to be greater than 15. Probably is going to be... Is it 17 on the dot? Okay, 17. Okay. Do you notice how little I'm writing down? So if you go back and you have to watch this, what should you do? Listen to the video, right? Listen, because you're not seeing me write a whole bunch of stuff, are you? Right? Because you guys are giving me the answers verbally. All right. Estimate the value of the square root of 142. What is this? What's the closest perfect square to it? 144. 144. 144. If you need to make yourself a list of perfect squares, that'll help you out. Okay? It's really close to the square root of 144. It's going to be less than 12, but it's going to be close enough to 12 to round up to it, right? All right, so the closest integer is 12. Does that make sense? Okay. Like I said, I'm not writing things down. What's the closest integer to the square root of 82? 81. So what is the closest integer to the square root of 82? 9. Very good. All right. Is this a perfect square? Square root of 16. Is that a perfect square? What's it come out to? 4. Very good. All right. Last question. We want to see which side is greater. What's the square root of 25? 5. What's the square root of 64? 8. What's 8 plus 5? 13. What's the square root of 16? 4. What's the square root of 49? What's 4 plus 7? 11. So which side is greater? All right, so we're going to have our little alligator eat the 13, right? All right, that's it. We did them all. Do we feel pretty good about it? Okay, can I show you guys something real quick? All right, let's say that we have a number that is not a perfect square. Somebody give me a number that's not a perfect. Let's try like this 142, right? 142. And I want to put this in simplified radical form. Are you guys familiar with simplified radical form at all? Maybe not. Okay, so let's say we don't want to estimate, but we want to get an exact answer. What I would do is I'm going to divide 142 by prime numbers. So for instance, I can divide that by 2, correct? And I'm going to get 71. That doesn't work very well because 71 is a prime number. All right, so the square root of 142 can't actually reduce. Let's try something a little bit bigger or even better. Let's try, let's try 66, okay? Because 36 is a perfect square, so we would just get 6 and 6. So this would be what, 2 and 33? All right, that's 3 and 11. That doesn't work either because I wind up with all prime numbers out here. So the square root of 66 doesn't work. Let's try something a little different. Let's try, how about 84? 84 seems like that would be a little bit better. That would be what, 42? And that would be what, 21, which is 3 and 7. Now, because it's a square root, I take out doubles of numbers. So this would actually be 2 square root of 21. Because what I would be left with is 3 times 7 in there. It's a factoring tree. Yeah, do we remember this at all? This would be the more exact answer if we had the square root of 84 and I said, what is the simplified radical form? My answer would be 2 radical 21. Does that make sense? Okay. I know that's not in this lesson, but I kind of wanted to brush up on it because we might get there later, okay? All right, let's hit stop, and you guys can get to work.